Greetings and welcome, friends. Mr. Waddy here. We've been going over sections kind of 8.1, 8.2, a little bit of both, talking about graphing quadratics, which turn out to have a graph that is a funny curve named a parabola. And for this problem 4 from 8.1, I'm jumping around. So the example they'd want you to see is the 8.1's example 1. It says identify the characteristics of the quadratic function and its graph. So the first thing I want to identify is the vertex. And the vertex is the lowest point on a upward facing parabola. It's the highest point on a downward opening parabola. It's the point in which the graph changes direction, and this vertex appears to be right here. Careful, looks like they swapped the scales on us, friends. That's -2 and up 4 by the looks of it. All right, so there's the vertex. Now, could this be a regularly facing parabola? No, I don't think so. Well, either way. So there's the vertex. There's this other idea called the axis of symmetry, which is the vertical line that the graph is mirrored over. All right, so axis of symmetry. And the axis of symmetry is going to be a vertical line, so it's going to be of the form x equals a number. It's a line, not just a number. And that equation would be x equals the -2, the x coordinate of that point. So x equals -2 will be the axis of symmetry. Now, regarding this parabola, we would describe it as opens up, because it's kind of, right, facing in this upward direction. So that's what you would describe that as. Parabolas that open up will have a positive leading coefficient for their squared term there, but we'll get more into that today. And I guess we could talk about domain and range. Domain is just going to be everything, set of all x, such that x is everybody. Technically, I would say x is an element of the real numbers, but you guys don't know that notation. So I'm just like going to say x is x. And the range, let's see, in terms of the possible output values, the y values, it looks like it's everything that is bigger than 4. Right? It doesn't exist for this space down here. So I'm going to say that that's the set of all y such that y is greater than or equal to 4. Right? Because it only exists for those values pointing up. You could also say that it's decreasing for values of x less than -2, and it's increasing for values of x greater than 2. But I don't know if they wanted us to say that. Decreasing when x is less than -2, and increasing when x is greater than that -2, right? -2 being this x coordinate as well as the axis of symmetry. Regarding parabolas, we talked about their slope yesterday, how they get steeper and steeper, faster and faster. So the word slope, in the way that I'm using it, is not going to be the most appropriate term, at least in the way you'll see me implement in these next problems. But yeah, there you go. So there's a bunch of information about this parabola. What if I ask you, does this parabola have any x-intercepts? You think so? No? Does this parabola have any x-intercepts, do you think? Does it cross the x-axis? It looks like it crosses the y-axis. Where does it seem to cross the y-axis? Looks like, yeah, about 8. But as far as crossing the x-axis, this parabola... Oh, yeah, the axis of symmetry isn't a part of the graph. It's just a way to, like, help describe the graph, or it's a helpful thing to know. But yeah, so no x-intercepts. We'll talk about those in a little bit. as well. So let's jump into some more of these problems. Here's question 5. It says graph the function. So one of the ways that we were doing this, different than the book, was we identified first where the vertex was. This -3 is a shift down. So 0, -3, instead of 0, 0 will be our vertex. So 0, -3 will be my starting point. And then this value in front of the x is 1. So my slopes, quote unquote, are going to be up 1 over 1, up 3 over 1, up 5 over 1. And these numbers are the consecutive odd numbers. Consecutive odd numbers. So if I go up 1 and over 1, there's a point. Up 3 and over 1, there's a point. Up 5 and over 1, there's a point. And so this is a way that I can generate points on my graph rather quickly, just like we did back in the day with y equals max plus b for the equations of lines and their graphs. Now, since this vertex is going to be the lowest point on this parabola by the looks of it, the axis of symmetry will pass through that vertex, and all of these points I can then mirror over that imaginary line there. There we go. So there we go. Also, I could find those points by going up 1, backwards 1, up 3, backwards 1, up 5, backwards 1. And then I'm going to draw the best non-pointy bottomed parabola. Terribleness, Mr. Waddy. You are just not good at drawing parabolas, but somehow you get paid for it. That's all right. So there you go. So that's a way to quick graph these. You could make a table of values, but come on, I'm a mathematician. I make tables of values for graphs that I don't know what they look like. But when I know what they look like, I use my intuition, I use my logic, I use pattern recognition. That's what we do. All right. So here we go. Here's question 8. Oh, this one's a negative one. A little bit negative there. Let's do the same thing. Let's find the vertex. So this one's shifted down 7, right? So 0, -7. So in terms of a transformation perspective, vert shift down 7, right? And in terms of the vertex, it's just going to be at 0, -7. So let's plot that point right about there. Bing. And the number in front of the x squared is -1. So that means my slopes are going to be down 1 over 1, down 3 over 1, and down 5 over 1. All right. So let's plot those points. Down 1 over 1. Let's see. Make sure my scale is correct. Okay, yeah. Down 3 from there and over 1. And down 5 from there actually just barely goes off my graph and over 1. And then mirror, mirror on the wall. Who's the most parabola of all? Here we go. Let's see. And I will make... Oh, guys, that was the coolest curve ever right there. Guys, it looks like I'm better at upside-down parabolas. Huh. If I turn on the touch controls on my writing tablet, I could just actually, like, straight up rotate. Isn't there a way I can just like rotate the canvas? That's what I should do each time. I'll just like rotate it and then draw it differently. That would be craziness. But yeah, we'll see. All right, here we go. Oh, new challenge. It says find the zeros of the function. Now, my friends and I, we didn't quite get to that yesterday. But some of my internet friends will have, or future generations will have. So let's see. So we're going to both learn and do this problem at the same time. It says a zero of a function f is an x value for which f of x equals 0. A zero of a function is an x-intercept of the graph of the function. So a 0 is going to be an x value, so it's just a number. and I'm looking for the x-intercepts of this graph. So let me speed graph this. So this minus 36 tells me my vertex is going to be 0, negative 36. My sloppy slopes, it's got a 1 here. You're probably sick of writing these. Don't worry, they're all going to be different today. 1, up 1 over 1, up 3 over 1, up 5 over 1. So, plot that vertex. Man. Looks like these are counting by 2s, so negative 30, 32, 34, 36. Hey, what do you know? I just barely gave us enough space on my graph. And I'm going to go up 1, which is half a grid mark, right, over 1. Up 3, so that's 1.5 grid marks over 1. Did I? No, I did not go over 1 there, did I? Like here. And then up 5 over 1, so that's going to be 2.5 grid marks over 1. Did I give myself enough space here? I think I did, yep. All right, guys, I'm not there yet. So to predict my x-intercepts, I'm going to have to keep going by some more odd numbers. What's the next odd number after 5? Anybody? The next odd number after 5. All right, I think people are still tired today. The next odd number is 7. So that's going to be up 3.5 grid units. So 1, 2, 3, 4, 5, 6, 7, and over 1. And the next one would be 9, which would be up 4.5 grid units. I'm at negative 20. So that's going to actually just bring me to negative 11. And then the next odd number is 11. Hey, wow. So up 11 and over 1. Wow. So if I quickly mirror, nope. Quickly try to mirror some of these points like so, like so. This is a tricky graph right here. And let's see if I can do my whole page rotation trick. Ready? What? Crazy Mr. Waddy. You and your creative laziness. Nope. Yeah, I'm better at drawing parabolas upside down. You gotta know your strengths and not frown. There we go. Look at that. Genius. So as far as the zeros of this, it said the zeros are the same as the x-intercepts. So the zeros, which actually zeros plural is zeros, right? Obviously. But mathematicians spell that both Z-E-R-O-S, and I believe English ones or Australian ones might throw an E in there as well. I believe I've seen both. So where does this cross the x-axis, friends? What numbers are those circles I drew at? There's 2 of them. 2 x-intercepts. Anybody? Wow. Alright. It's negative 6 and positive 6. The zeros of the function. And I was able to read those off of the graph. Interesting thing about parabolas is that they can intersect up to twice for an x-intercept. So that's kind of interesting. It is also possible for them to intercept the x-axis once when the vertex happens to be on the x-axis. And we've even seen them not intercept the x-axis, as we saw in this problem. Notice no x-intercepts there. All right, last one real quick. I love this one. This one's like clues. Sketch a parabola with the given characteristics. All right, vertex is at 0, 4. So plot it. Bam. There's my vertex. And it says, and one of the x-intercepts is 2. So if the x-intercept here is 2, how could I draw a parabola with only 2 points? Huh. Well, I could mirror this over the axis of symmetry, and there would be another one here. Technically, this one we got lucky. If I went down 1 over 1 and down 3 over 1, those points would have been included. But even if I don't know that, because I can't always predict that. My parabola, you guys kind of know the shape now. Maybe you could get a rough idea of what it looks like based off of just 3 points, if one of those points is the vertex. If you don't have the vertex, it's way harder to sketch the parabola. All right, well, thank you for watching, mis amigos de internet.